Well, good afternoon, everyone. Some of these cool technologies that we've seen so far are all technologies that we build into our solution set for connected production. And we're going to talk a little bit about connected production this afternoon. Connected production actually is our connected enterprise vision in the oil and gas industry. And it's quite interesting when we talk to customers, we ask them what is their interest and appeal in accessing more of the information they have. And they will tell us essentially the same things. They see production goals as moving targets in a fairly uncertain outlook and economy. They look forward 10 years and they see growth continuing, but at a much slower pace than the previous 10 years. They see capital investments diminished, and they're forced to do more of their assets and existing infrastructure, so they're being asked to do more with less. They also have a workforce capacity issue. During the last downturn, they unfortunately had reduction in workforce. And now in this cycle, trying to get back to those same levels or the same skills is becoming challenging. They also know around 20% of their workforce is within 10 years of retirement. In fact, in a recent survey, 22% of oil and gas executives said that skill gaps in their organization was adversely impacting operations. So they see the opportunity to look at the data they have inside their operations. They think, and to Michael's earlier presentation, they see the attractiveness of using advanced analytics, predictive analytics, to help them predict failures in their infrastructure. They see the value in using that data to drive operational efficiencies and extend the life of assets in the field. And there's a lot of data. I hear the term big data. I hear now the term torrential data. There's just tons of it, right? But that data is not always stored. It's not always connected. It's sometimes in silos. It's sometimes not being produced from contemporary technology. It's older systems. So there's an idea that they need to bring that data together, place that data into a common data format. The other thing they realize is that huge amounts of data is unstructured. I remember as a young engineer, one of my jobs was to pore over Modbus maps and figure out what the value 210 was in register 1000. But it's very difficult to use that kind of format of information to feed advanced analytics engines or make informed business decisions. So they recognize these challenges, but they see the value in being able to access the data and do more of that information. So you see this graphic behind me, it shows this cone, and really you think of the data, all the information that's available at the top of that cone. And at the point where operational and business decisions are being made, based on the sort of current situation with potential leaks in the data, in the infrastructure, and the way data is captured, the way it's contextualized, decisions are not really being made with the fullest picture available. So in order to really take advantage of some of the things that Michael talked about, we need to make sure that as much of the data is in context, is available and is being used in that decision-making process. So let me ask a question and see if we did a show of hands here by consensus. In the context of digital transformation, if you don't trust the data, then nothing else matters. If you don't trust the data, nothing else matters. So give me a show of hands if you agree with that statement. If your hand is down, please put your hand up. If you don't trust the data, how could you make a decision? So, I agree. You have to trust the data. And so there's lots of work to be done before you can get to that point. So another way of thinking about this is rather than say, hey, if you don't trust the data, nothing else matters, maybe another way to phrase this is digital transformation starts with high integrity data. Digital transformation starts with high integrity data. So what do we mean by that? Well, Within connected production, we think of data being high integrity. We want to make sure all that data that's available meets a basic set of requirements. There's a few here on the graphic here which we'll just touch on. So it seems obvious, right? Data needs to be reliable and secure. Well, I think secure is a fairly obvious thing to say, but what does reliable mean? Well, it means, at least in our context, that you use contemporary technologies that guarantee delivery of the data from the field to the server. So if you have an edge device in the field that's capturing data, pressure, flow, maybe that device is not always connected. Maybe the infrastructure means that oftentimes that data is being stored locally. So you need protocols and technology that ensure when that device is connected, it guarantees delivery of the data, and the system takes that data and inserts it in the appropriate time slot with all the other information. The other thing that we think is really important in high integrity data is that data has to have meaning. I used my Modbus example earlier. So data needs to be contextualized. But more importantly, that contextualization needs to stay with the data wherever it's used in the data ecosystem. So even if a third-party piece of software is accessing that data layer, they should be able to access that data in context so they can make meaningful decisions in using that information. We think of high-integrity data as being timely and available. What we mean by that, when we talk to customers who are on this digital transformation journey, they simply don't rip out all of their assets and deploy this massive upgrade to all of their infrastructure. They start small. They do a pilot program. They give us access to a handful of wells. And we put some artificial lift around those wells. We connect it to a connected production server. Then we monitor that data for several months. And we demonstrate the value of using this platform for optimization. So now the customer is happy, but he wants to scale that up. He wants to scale that system to a larger amount of data. So the system needs to be able to provide that data against a guaranteed set of performance from small to very large, so the data is always available. Additionally, you need to build into that architecture levels of redundancy where appropriate, so you eliminate common cause failures that would disconnect the data from being analyzed. And lastly, data needs to be actionable. What we mean by that is that based on an event or a condition anywhere in the system, you should be able to trigger a workflow or some kind of action to automate manual processes. I think Dave earlier on was talking about pushing things to the edge device, and he's absolutely right. So whether or not you initiate a workflow or an action in the field at the device, or you initiate a workflow or action on huge amounts of data in the cloud, all of those actionable events should be able to be initiated in the system. So, to solve these challenges, I mentioned at the very beginning, we have this technology, this platform, this set of solutions called connected production. And connected production is our connected enterprise vision for the oil and gas industry. And you saw Michael and Dave and others and John this morning with Howard talking about PTC. All of these technologies are potentially part of the connected production solution set. But connected production provides orchestration of the data to ensure that the right data is delivered to the right people at the right time. So it includes edge devices, secure communications and gateways, this concept of high integrity data as part of its delivery, an information platform for visualization, taking advantage in the future of FT Innovation Suite that you heard about this morning from John Genovese. And connected production can be deployed on-premise or in the cloud. Again, we find customers have a strong opinion about cloud v on-premise, and often it's tied to where they are in that digital transformation journey. I actually remember presenting this topic to an oil company in the Middle East, and they're very sensitive about putting production data in the cloud. And I explained to them that this could be a cloud-based delivery. And they pointed to the sky and they said, there are no clouds here in the Middle East. So I guess the message was clear. One other concept I want to touch on here is this idea of intelligent assets. And what is an intelligent asset? Well, an intelligent asset is a collection of hardware and software that represents data from an asset or a piece of equipment. And the idea of an intelligent asset is it allows us to, when properly provisioned in the field, it allows us to automatically configure that asset inside a connected production. So a good example might be a rod pump controller. So a rod pump controller is used as an artificial lift method to extend the life from a well. So with connected production, when we deploy a Rockwell Automation rod pump controller to that well, and when it's properly provisioned, connected production can connect to that asset, detect that asset type, give the data its sending context, and automatically generate dashboards, initiate workflows, hand off data to analytics engines. And where a third-party software needs access to that asset, automatically send that data in context to that third-party system. One of the great advantages of intelligent assets, it reduces the need for multiple skill sets. Traditionally, if you were deploying that rod pump controller, maybe now you need to configure in the historian, that data set. Maybe you have to configure an OPC server to send that information to a third-party analytics system. Maybe you need to cut and paste and copy some dashboards and tie that data to the dashboard to visually represent the data from the asset. All of those potentially take multiple skill sets. And companies today have a reduced skill set. So having the ability to automatically configure and provide those dashboards with very little configuration saves days in configuration. Not only does it save time in deployment, it also reduces errors because the configuration is done, the orchestration of the data behind the scenes is handled by connected production. So in addition to providing this foundation for high integrity data, and the ability to orchestrate that data to deliver it to the key stakeholders. I've already mentioned that we have a number of additional tools that allow oil and gas producers and operators to gain operational insights to that information. So production and operation workflows, which allow you to automate manual processes, role-based visualization, I mentioned dashboards earlier, but making sure that the dashboard that you're seeing is appropriate for your role in the organization. So a financial manager needs to look at different sets of data than maybe a maintenance engineer. And lastly, scalable analytics. The idea that we can hand off data to multiple analytics engines simultaneously. We can deliver a data set from an asset or a group of assets. That data can be analyzed, returned back to connected production, and we can either take some action, we can display that information in a different format or a different way. So Michael earlier was talking about advanced analytics. So behind the scenes, we could be sending contextualized data from field assets to an advanced analytics platform, which is processing that data, making predictive trends towards the state of a well over time, and return that data, and we can visualize and then provide information to the operator on what to do for that trending state of the well. So in short, connected production puts high integrity data from your assets in the field at your fingertips. It really helps to focus on maximizing well recovery, improving operational efficiencies, and gives you the ability to consider enhanced production agility in the way you respond to field events. So just a couple of examples of where we've seen connected production in use today. So customers are using connected production in a number of different ways. Here is an example of a customer who, after assessment, realized they have a number of manual processes for looking at the performance around a well. So this involved engineers collecting data manually, coalescing that data into spreadsheets, doing an analysis and making a recommendation on chemical injection related to wax management around the well. And wax buildup can impede and slow down operations. So the problem with this process, it took a lot of time to do that analysis. And by the time those recommendations were made to the production team for adjustments to make in their chemical injection, other parameters had changed, and so the process was lagging. So by implementing connected production, they automated that data collection process, provided analytics that allowed us to do that analysis in real time, and close the gap between analysis and action. And based on per well or per well pad savings, the customers seeing real benefits using connected production. Here's another example, slightly different. Here we have a customer in the US that has a very large number of disparate systems to control their production and as well as their process safety. They found it really difficult to maintain these disparate systems. They had workforce issues. These are old legacy systems, and not everybody knew how to do the maintenance. And not only that, they were different systems and different technologies, so very hard to get efficiencies and benefits. So a combination of equipment upgrades and connected production provides a more standardized approach to control and safety with access to that data across multiple assets. Another key point here is that this customer, like many customers, has very limited capital investments. So the idea of saying, well, we can only really make this effective for you if you take all those systems out on day one is simply not viable. So the ability to at least connected production to existing field assets while they go through this phased migration was a huge benefit to that customer. So coming to a close here, the digital journey is simply not a set of linear steps. And it's really constantly evolving. And we find when we engage with customers early on, they may just be in this process of assessment and planning. They're actually not even sure what digital transformation means to their organization. So having a partner that can work with you through that evolving process, from asset and planning to actually integrating a technology platform, to the testing and scaling of that platform. I mentioned earlier, most customers will just allow a very small pilot to initiate a discussion around digital transformation. So providing the ability to work with that customer through those piloting processes while they then see the value and benefits, and then going back and revisiting the original assessment and planning to determine if you've made the right choices is a key part of this process. So it's only till you've done those things can you start to realize and do the analysis and visualization and finally reach that sort of end point of optimization. So I want to thank you for your time this afternoon. And we have connected production here at the show. We have some of my team here that can answer all your questions around the sort of under the hood technology that we use to drive this. And with that, I'm going to hand you back to Jim Winter. Thank you.
Nice job.